Okay, so we're going to talk about one of the biggest real-life applications of quadratics. A lot of functions in life can be represented by quadratics, and a lot of times you end up asking yourself for what the maximum point of that thing or the minimum point of that thing is in a quadratic. Well, if you remember what a vertex is, it's the highest or lowest point. So maximum and minimum is just another name for the vertex, because maximum would be the biggest point, so there's a maximum, and minimum would be the smallest point. So quadratics can only have either a max or a min. They can't have both. So we're going to look through a couple of these problems and try to find the max and the min. So for this first one, we're going to find if it has a max or a min, and we're going to state what it is. So when I'm looking over here, again, another name for the max and min would be the vertex. So we're going to find the x-coordinate for the vertex, which would be negative b over 2a. So when I end up plugging that in, I should get 16 over 4. And that is going to just give me 4. And we're going to end up graphing this so that we can tell whether that vertex is a max or a min. So I'm going to pick 1 point below, and I'm going to pick 1 point above. And then we're just going to plug all these things in just like last time. So 2, 3 squared minus 16 times 3 plus 33. And we're going to see what this gives us. And this right here just gives us 3. Plug this in, so 2 times 4 squared minus 16 times 4 plus 33. Again, then I'm going to put that into my calculator and see what that gives me. That gives me 1. And we'll input this over here, so 2 times 5 squared minus 16 times 5 plus 33. And when I input all this into my calculator, I get this to be 3. So my guess is that this vertex is a minimum point because there are values that are higher than it. So it definitely can't be the biggest point, but we're going to look on the graph just to make sure. So again, if you remember our table over here, it was 3, 4, 5, and we got 3, 1, 3. So if we graph it, we'll have this, and that would be the wrong points, since it is 4, 1, 2, 3, 4, and up 1, and 5, 3, and 3, 3. So we get this U shape up here, and that is definitely a minimum point. So our min for this thing would be at the point 4, 1, and it would definitely be a min. Again, this 4, 1 is the same as our normal vertex, and in this case it's a minimum point. Let's do one more example. So again, we have this function right here, and to start out we're going to find the vertex, because the vertex is either going to be the max or the min in this situation. So we have to find the vertex, and I'm going to do negative b over 2a to find what the x value is. So it would be negative 2 over 2 times negative 1, which would give me a positive 1. So my x value is a positive 1. Then we're going to pick 1 point below and 1 point above and fill in all that information. So this would be 0 squared plus 2 times 0 plus 1. So that's going to give me just 1. I'm going to have negative 1 squared plus 2 times 1 plus 1. That is going to give me 2. Then we're going to do the same thing with 2. So I'll have negative 2 squared plus 2 times 2 plus 1. And that's just going to give me 1. And this time we can kind of see that this looks to be a higher point and everything else looks to be getting lower. But let's graph it to make sure. So when I graph these points, I have 0, 1, 1, 2, and 2, 1. And as you can see when we graph, we get this downward U. So this is definitely a max. And the max would be at the point 1, 2. So these are the two examples that we've tried. You've seen one max example and one min example. What I would do now is try the different problems and see if you can find whether these things are maxes or mins.